Hello, everyone, and welcome back to the next episode of Data Analytics Chat, where we explore the exciting world of data analytics. I guess a lot of changes is happening. We'll also discuss the evolving landscape and looking at the challenges that this brings. So today we've got an interesting topic, and I guess to move away from all the buzz of LLMs, and we're looking at TinyML. So an interesting topic for me. Yeah, if I'll be honest, before Bartmoss, who we have as a guest, I did not hear about it, if I'll be honest. Let me introduce today's special guest, Bartmoss St Clair. Welcome, Bartmoss.
Thanks a lot, Ben. It's a pleasure to be here. I was very excited when you reached out to me to join your podcast. It's like my second podcast now. So I don't know, it's getting popular to do this, and it's so much fun. My only problem is you can't get me to shut up. So you got to tell me when to cut.
Good luck. You've got experience already. So, yeah, do you want to briefly introduce yourself?
Sure. As you mentioned, I'm Bartmoss St Clair. I background in mathematics and physics, but that was a very long time ago. Since then, I've been active for 11 years in the AI and management industry. I founded my own company, worked on a lot of different projects. I've worked for really big companies like Samsung and Harman. I've been a guest researcher. I've worked a lot over the years with open source, which I'm really proud of. And that's something I want to give a shout out today, of course, too. I also work as an AI advisor and micro consultant, and I currently work as a head of AI at Language Tool. So a lot of things to introduce there. I've been doing this for a very long time, and it's always nice to talk about these things. So let's get right into it, shall we?
Yeah, definitely. I think after your experience would be beneficial to a lot of the audience. I guess if you were looking at, obviously there's a lot of buzz in IoT, wasn't there? And it's obviously, yes, the new technologies like Gen AI overtook the headlines, but I think it will be, I guess like mobile phones, they used to be really big and then they got smaller and smaller. Maybe it'll be a similar situation here.
Yeah, I really think that on one side, everyone talks about LLMs and models aren't just getting bigger and bigger, they're also getting smaller and better too. And this is something where I think there's a huge business impact. And IoT was a buzz, but I think it's something that it just takes time to mature, really. And that's what I definitely want to talk about today. Some of the hurdles there and some of the problems and some of the solutions and how I think this is going to be a huge industry in the future and what kind of impacts it's going to have. I'm very excited to be talking about this today.
Brilliant. All right, let's roll on then. What is TinyML and why is it becoming increasingly relevant in today's tech world?
I think it's a good question to start with right there. What is it exactly?
Yeah.
TinyML, like the name implies, tiny machine learning. We're talking about much smaller models than what you would see deployed, for example, with LLMs and things like that. But there's no quite definition exactly of what size. That changes over time, just as the term LLM changes over time. What was an LLM 1 or 2 years ago might not be now. But generally, it's a field of study that explores the development of machine learning models that are more for low power or low resource devices, such as microcontrollers. You could even lump in mobile phones in there, small computers such as Raspberry Pi, things like that, that people can run at home instead of having to run in the cloud. But that's quintessentially what it's about, and that very much connects into IoT, the Internet of Things.
Yeah. Okay, cool. And then, okay, so what's the advantages of TinyML over statistical learning approaches?
Yeah, there are a lot of advantages. On one side, low power consumption, obviously with smaller models and things that run on edge devices or things like microcontrollers, etc. There's a very low power consumption, so they're optimized for limited battery life and things like that. For example, on your phone, you can have reduced latency, which is something really helpful. A lot of times, people don't really think about this as end users, but we're always trying to optimize latency of models because people don't like when something takes too long and they complain about it, right?
Yeah.
Reduce latency when something's running right on the device, right in your home or in your pocket. That's something that people generally like. There's, of course, the matter of privacy, which is something that's dear to me. I think a lot of users nowadays are getting more privacy conscious. I'd like to see more of that, honestly. As someone who works a lot in open source, people running their own things on devices, that means if that model is there and people aren't collecting so much data, they have more privacy. And I think that's something that should not be underestimated in this industry, that I think there is a move slowly for more user privacy. And I think that's a big thing. And of course, the biggest thing for business here, obviously, is the lower cost for business, because When you run something in the cloud, that costs money. And yes, the prices come down for these things, but it costs a lot of money and
Yeah.
scalability issues. But when you have things running locally on people's devices, you don't have to pay for that. So you could save some money in the end as a business, which is something that's really fantastic. I think everyone agrees with that. I think that's going to be a big driver for us here.
Yeah. So do you think that's going to be the key driver then? Is it more to do with money? Because I guess obviously a lot of people have got cloud on premise, and obviously cloud is obviously not cheap. So do you think do you think that will be the key driver then, just the cost, or do you think it'll be something else?
I think cost is definitely one of the things. And on the other side, it's like, how exactly do companies make money a lot of times when they're giving them away for free? And currently they do it by collecting data. And you would have to see some sort of sea change in that mentality when it comes to tiny ML devices. But also keep in mind that we're talking about devices that are more for the Internet of Things or running locally on your phone or otherwise. And so the use case is also a bit different. And I think we're not seeing so many of those devices yet. There are some, but I think there will be an explosion in very smart, capable devices coming out in the near future. And I think that's really just a matter of time. But it's engineering wise, it's quite complicated sometimes.
Yeah, I bet. And yeah, I do agree with you. I think, like you mentioned, privacy is a key thing for everyone, isn't it? Really, business and people. And that's only going to grow more and more as we in the future. Well, I guess moving on then, what are some industry sectors or use cases where you see TinyML having significant impact in the near future?
Even now, but also in the near future, a lot of cases such as computer vision, visual wake words, keyword spotting, which is like audio wake word, like when you wake up your Alexa device or something like that, that runs already locally on your device, right? Predictive maintenance, gesture recognition, which is something very cool, industrial machine maintenance. There's so many different areas in industry, but all from B to B to C that can be impacted here and already are impacted in some way. But when you think about the future, you have to think, we'll be able to run a chat GPT like model in your pocket. And what do you do then as a user? And what are the users expecting there? If you can keep scaling up the models, you can keep them going more and more to a certain point. But if you can make them smaller and just run at home and have perfect privacy, that's also a very interesting thing to have, less latency. So I think the use cases that I've listed are mostly with things that we can do now with technology. But
Yeah,
the big question is, when we have the capability to run something like a chat GPT in the palm of your hand, what do you do with that? It's a big question.
very interesting
Yeah.
how businesses implement it and the future. Obviously, you never know what's around us. You don't know what's around the
Exactly.
corner.
Exactly. And as for sectors and business use cases, there's a lot of different things that can be done there with healthcare, patient monitoring, for example. That's something, especially maybe you don't want that kind of information going in the cloud and you want to have a device for monitoring your patients
Mm.
there running locally. Agriculture, of course, there's even some fun experimental kits you can use with sensors nowadays that you can build at home yourself with a microcontroller for monitoring soil and things like that. That I think going to be something big. This future promise that we've always heard of about smart cities, that's something that could be a possibility with this
Yeah.
kind of technology, with traffic and infrastructure management. And of course, in manufacturing, I think that would be another use case right there of, like I said before, predictive maintenance. That's something that I think will be really big. There's a lot of applications for this, and I can see this going down many paths, and I'm not specialized in all of them. So it's hard to sometimes speak about a lot of these use cases. But for me personally, I'm interested more in the wake word area of building wake words so that you can wake up devices like that are your own voice assistants. That's what I developed with the secret sauce community. So that's something that's where I got originally engaged in this. But
Yeah.
like I said, there's so many use cases for this kind of technology.
Yeah, I guess there's endless, really, isn't it? I think it's I think that's the whole thing about business, isn't it? It's constant development, continuous development. Is so many things can change and get improvements, which obviously new technologies bring new opportunities and
Absolutely.
also challenges.
Absolutely. Absolutely. It's definitely a challenge. That's for sure.
So then, what's the example? Can you provide examples of how businesses are like currently leveraging TinyML?
Yeah, absolutely. I used to work at Samsung and we developed a voice assistant called Bixby. And when you wake it up I don't like to say the wake words out loud in case I wake up someone's machines over there, but I think that's not a thing, but I think people understand what I mean by waking up the voice assistant. Um, this is something that would run on the device itself. And because it had to be low powered and had to be local and had to work 100% of the time. And that's where I first got exposed to TinyML before I even knew that it was called TinyML. And that was a huge case there. And everyone who uses Amazon's Alexa or something like that, they're already using this technology. They might not realize it, but a lot of that is running on the device when it comes to the wake word system. The other areas, you can have smart wearables, like with your smartwatch. Some of that does run on the device itself because it's not always connected to the internet. So for health metrics, monitoring in real time, like this said, agricultural sensors. This is something actually I'm building in cooperation with my wife currently, just for at home, where we want to monitor our plants and the moisture. So I think that's a real interesting use case. Water usage, industrial sensors. Gosh, there's just so many different areas. Like with sensors specifically, usually a lot of it has to do with sensing things in an environment and needing to have that somewhere where you might need low power. It might need to be small, something that doesn't require the internet, or for privacy related issue.
Interesting. No, it's good you're doing it in your own time as well.
Yes, I work with a huge community of people out there, and we just hack away on all of our little projects. And it's also a good way to keep focused on what's going to happen in the future, because sometimes there are no products for these things, so you build it yourself and you get out your soldering kit and everything, and you work on microcontrollers and things like that, which is immensely fun. And I highly recommend anyone, even if you don't have experience with that, you can learn to solder in 10 minutes and you can build these things yourself. And it can be a headache, but at the same time, it can be really fun when you get the things working.
Brilliant. What's the main challenges or limitations for data science teams to implement these ML solutions?
But that could be a podcast all by itself. What are the challenges there? But I mean, a lot of the key challenges, not just for data science teams, but for developers in general here. Firstly, is model compression, that you need to get a model really small to run, and that very depends on your device, whether it's on a mobile phone, a Raspberry Pi, a microcontroller. Those are very different things, and because of that, it's also quite difficult to sometimes for the code to actually get the model to run inference. It's not something where normally when you do some sort of development work, especially with AI, you're just working in Python mostly. And for some of these systems, you can't just get it to run on Python. You have to use something like C, C++, or Rust or something like that. And a lot of people who are in ML development don't really know those things, or you have to do work with microcontrollers, embedded systems. And embedded systems engineering is not the normal ML ops and AI based task. And I think that's a huge challenge, but even more considered as a challenge, I think the frameworks. There's a lot of frameworks that come and go. And that's what we saw in the last 10, 12 years with typical machine learning as it's blossomed now. Most people use PyTorch now, and it's become very standard. A lot of people using also Hugging Face on top of PyTorch. And these things are very standardized now. And back 10 years ago, 12 years ago, it wasn't exactly like that. And I think that's where we are now. So there's a lot of frameworks that are slowly starting to come out now. And most people right now, they use TensorFlow Lite for a lot of these things, but it's a bit outdated. And I have heard that PyTorch is coming out with some new stuff there, but they actually have released something new. I haven't checked it out myself yet, but I think there are things coming out, but it's a huge bottleneck for us. And I think that's one of the big areas where you have to think about software wise. How do you get your model compressed to run on your device in real time? How do you run the code and get it on the device? How do you test the device in an actual real environment to get it to make sure it works? And how do you do that whole process? And it's a bit harder than regular stuff. I can say that's for sure.
It sounds a lot more trickier. So
Yeah, it still is. But hey, like I said, 10, 12 years ago, getting models to run a GPU at all was really hard. And training models back then in the way we do it now, that it's so much easier, and the tools are so much more standardized. And I think we'll see that too. And there was a huge hype starting a few years ago with deep learning, and then computer vision became very popular before NLP. Although I was working in NLP back then, it wasn't the cool thing it was nowadays. And I think we're seeing the same thing here. We're about 10 or 12 years out. If you look at the time now, how long that'll take to get to the point where we are now with TinyML, that's anyone's guess. But I think we're about like 10, 12 years ago equivalent.
I'm interested. Have you obviously touched on software then? And then what role does hardware acceleration impact, like the efficient TinyML deployments?
Yeah, that's a really good question. I think most devices don't even really take advantage of that so much. They're just running on CPU. Like most of my things that I create at home are just running on Raspberry or Raspberry Zeros. Someone recently got Stable Diffusion working on a Raspberry Zero 2, which is absolutely insane. I didn't even think you could do that. But most of the time, we're not taking advantage of GPUs or TPUs or something like that. NVIDIA came out with Jetson Nano a while ago. Google came out with Coral with TPUs a while ago. But I think those are mostly just for hobby kits, really. People aren't really using them more in production. Now, of course, there are different types of quote unquote AI chips on phones nowadays, but that's just one use case. And of course, it's varied, but I think nowadays it's mostly people running things efficiently for inference on CPU. But I hope in the future there will be a lot more devices available that actually accelerate. And I think there will be. I do see a lot of investment in that. And I think, like I said, it's a matter of time. It was the same thing with GPUs a while ago. Also, it wasn't much of a big thing.
Surely there'll be investment and there'll be new hardwares about. I think obviously, this should be. There must.
No, I completely think so because it was the kind of same situation all these years ago with also with what we now use as machine learning. And most of that was I was doing was also on CPU back then, and we weren't using fancy GPUs 12 years ago or something. Really, that was just kind of that was a new thing really for us. And nowadays, like you can't live without it. So I think it's just a matter of time. But of course, these kinds of special accelerators, whether they're GPU based or otherwise, do need to conform to low power usage. And I think that's also a really big challenge. I do think TPUs are quite interesting, and I'd like to see more development of the tensor processing units. But we'll see where that goes. Where there's money, there's a way. I think in business.
Yep, definitely. And then, how does development and the deployment process for TinyML differ to like traditional ML pipelines?
As I brushed on that in our previous question, there are extra steps involved. You might start off with doing how you would do it traditionally and training a very traditional model, which you could call it like a teacher model or something like that, a much larger model for annotating maybe a larger data set. Then you would have to create a much smaller model that's optimized for that hardware that can actually run, like I said, real time on the device. And that can be very tricky. For example, with wake word detection, that was something where we used a very small neural network to do it. And we had to really optimize for that. And that was something very challenging because it's always cooler if you can use a really big model or something like that. But given these kinds of constraints, you have to scale down a bit. And as I said, normally people use TensorFlow Lite for these kinds of things currently. I don't know how that's going to be in the future. This might be already outdated in a month or two, what I'm saying, the way these things go. But that's something where you might have to convert a model. Onyx is also quite popular, and you might have to convert your model, scale it down, distill it, something like that, compress it, use some sort of quantization or something like that with it. And on the other side, running the model, as I said before, can be something challenging. You need to actually create a runner for inference that uses C++ or Rust or something like that. For example, we have a couple of Rust developers in our Secret Soft AI community, and we're very lucky because I don't know how to write in Rust or anything like that. I'm just a Python guy at the end of the day mostly. And they build very optimized runners to actually run this stuff, and you have to then pack it all into a binary file that'll just run on the device. And yeah, those extra steps are quite challenging. Like I said, most data scientists and other people in this industry don't really know about those things. And 5, 6 years ago, most people in the industry concerned with data science and analytics also did not know much about ML ops either and how to really deploy scalable solutions. So I think it's just another thing that we're going to have to learn and add to our CV in the end, probably.
Another continue to grow, and I think more. Like you said, ML ops. That was just a bit more unknown back then. Now it's obviously growing in popularity. I guess something the same with here. I think is obviously all businesses are looking to improve, aren't they? And how can they improve processes, efficiency, and I guess new things come in. So you've got to apply it to your business. So then, bright, intelligent, and data science world, you're an expert in what you do. What are key skills for data science teams to develop or to acquire to effectively work within TinyML?
Like I said before, quantization and compression are quite important, but that's something that a lot of teams already do when it comes to, for example, LLMs and things like that. They're not just going with the full bore system. They're usually quantizing it or compressing it in some way to lower cost and lower latency. And so that's not a completely foreign concept, but really understanding the hardware constraints, because it's not a one size fits all. There's so many different types of hardware that you might want to have these things run on. So you have to really know specifically about that hardware, whether it's some sort of embedded system, microcontroller, like I said, Raspberry Pi that's more ARM based, or with the CPU, a mobile phone, or something like that. And so you have to have a lot of understanding when it comes to the constraint and how to get things running there. You have to know about the TinyML specific frameworks and tools, which are changing a lot. There's a lot of dead projects, but a lot of new projects coming out there. I have a lot of hope for some of the new stuff coming out. I'm very excited about that, and I actually can't wait to try it. I was actually glad to see that something new has been released. I haven't checked this in a while, and so just to do some research here, I found out that there's actually something exciting that I'm probably going to try it out in the next few weeks. So that's something very exciting. But you have to really know a lot of different things about this, both from the modeling side, the hardware side, optimization of your models, because you have to be really ruthless about optimizing these models. And it's definitely something that takes a lot of practice. And I don't think there's a lot of good tutorials, honestly, out there. It's something you just have to try and fail at a lot. But that's exactly how it was with ML in modern parlance in the last 10 years, 12 years ago. There was no like, okay, this is how you get it running. Just getting a model training on a GPU 8 years ago, 10 years ago was really challenging. So I think it's, like I said, a parallel to that.
Yeah. And I guess you touched on like the skill set of obviously Rust and C++, obviously is not as common as other programming languages. Do you see like data scientists acquiring them skills, or do you think it'd be like the C++ Rust developers adding like the data science sort of skill set to their resume?
Oh, wow, that's such a good question. I think it's a bit of both, because the term data scientist in its purest form doesn't include anything with ML ops. It doesn't include anything with being an ML engineer or a data engineer. But those terms, I think, a lot of times for these roles get muddled. And I've seen a lot of things with whether it's requirements for jobs, CVs, etc., where people add in a lot of these extra things, whereas a data scientist is something else. And I think there's a huge merging of these roles, and people just have these different titles with whatever their preference is. But whatever you call them, at the end of the day, they kind of have to have these skills. However, I can see definitely the appeal of having dedicated developers, just like you have front end and back end developers. The same would be true with TinyML solution on devices, that you have people who are very specialized in embedded devices with engineering, like system engineering for that, and things like that, or people who have a lot of experience with Rust or C++ or whatever language you want to develop that in. But I can see some other people getting interested in this. I do have a couple of friends who know Rust who are also data scientists. It's a mixed bag, but I think in the end all there's a huge convergence on these roles and titles anyway.
Yeah, as it gets more popular, I guess you kept like anything, you get more deeper into it, can you? Be more specialist in this. So only time will tell.
Yeah, we see roles for LLM engineers now, and I've seen things like that very specifically, and that's something that didn't exist a while ago. So yeah, I think on one side, it's definitely getting more specialized, but the kind of overall understanding that people have to have as a data scientist nowadays is just insane compared to 10 years ago. It's really crazy. It's really ballooned up. And I think that's something where when people are like trying to study for interviews or something, it becomes a real monumentous task of going back to university for, right? And but I think that's another podcast.
Yeah, you can't obviously with data science is just broad now. And even 2 years ago, there was you more techie data science type of roles. Now you're getting like data science with the product element. Obviously now you've got data science with LLMs is obviously really popular. It is evolving, so I think it's obviously important for you tech experts. You've got to continuously improve and develop and learn new skills, or you can just be left behind, can't you?
Oh, of course, like 10 years ago, if you just had a degree in math or physics and you could just show up without any programming like
Yeah, it's the job.
experience or anything, and then you got hired. 5 years ago, 6 years ago, if you could do anything in a Jupyter notebook with Python and maybe something like that, then you were pretty much hired. And nowadays you have to be like a full stack developer, it feels like, plus a data scientist at the same time. It's a bit crazy. And I hope that we can get a bit of handle on this specialization that, like you said, that people become more specialized and that we don't have such general expectations for data scientists. I would like to see that. But at the same time, yeah, I don't know if it keeps going like this, you're going to have to do everything, I think. Maybe ChatGPT or something like that could just help you. I don't know.
Interesting times. And I guess then how do you see it evolving the TinyML in the next coming years?
Oh, here's where I'm going to get everything probably wrong. I'm so bad at I'm
Yeah.
so bad at making predictions. I'm so bad. You can look at previous predictions I made, and I was pretty bad at it, to be quite honest. I don't know. But yeah, I think on one side, a lot of the algorithms will come more efficient. There will be more efficiencies there for more low powered, better algorithms. And the energy efficient hardware, I think there's something we can do well there. And the big thing, like I mentioned before, with the bottlenecks is really good frameworks that are very standardized and can work across multiple devices and not just one specific type of device. I think we're going to be seeing something like that become a lot more mainstream in the next couple of years. At least I really hope so. And that'll make it much easier to develop these solutions, which then will bring more solutions to market. And I think generally hardware will become more powerful as it always does. It's insane what you can get nowadays and how cheap you can buy like microcontrollers and things like that compared to 15 years ago or something like it's incredible. And that just keeps going. And I'm so glad that Moore's law is in some way, shape, or form still applicable so that we can just keep getting faster, cheaper, smaller devices. So I think that will definitely play a huge role, of course. And as I mentioned before, when you look currently, I saw a project where someone got Stable Diffusion running on a Raspberry Pi Zero 2. And that even blew my mind. I just didn't think that you could do that, honestly. And as this hardware and frameworks evolve, then these solutions will evolve and it will be in such an unpredictable way that I can't even imagine, but it's going to be awesome having very powerful devices right in your pocket, right in your home that emphasize privacy, I hope. And so just you can do so many things with this. And I'm going to keep trying to do stuff with it and I'm going to keep hacking it at home. And I can let people know what comes out of that. But I think that's how it all starts. It always starts in someone's garage, someone's basement, someone's hobby room, and then it just keeps evolving. Computers were the same, AI was the same, everything like that. It starts off with people just messing around, and then before you know it, you have a product that millions of people have in their homes.
Bang. Like, obviously, LLM was been around for a while, and then obviously the boom happened, should we say.
Absolutely.
Then I guess from the potential concern side, what do you think is going to be what should people be aware of when implementing these TinyML solutions?
That there is a hardware component to
Yeah.
this. You have to make sure the devices are resistant to attacks, especially if they have any sort of internet access or something like that. You don't want to invite attackers into people's homes like that. And you have to be careful with things like how it opens ports and things like that and the permissions it has with your router, things like that. Managing the life cycle of deployment in the field is something a bit different. Ensuring that these things are reliable over time and that they get frequent updates. People are a bit update allergic, I think, sometimes at home with updates and think about people's routers or something like that. It's similar. I think you need to see these devices more similar to someone's router or something like that. And people don't think about updating their router. A lot of these things update by themselves, which is great. But how do you update the models, especially if it's flashed on there, things like that? For example, I have my own vacuum cleaner, like robot vacuum cleaner, and I have to update that myself manually with my own stuff because it's part of an open source community. And I don't do that as much as I should, honestly. And I have to look out for that for updates, security issues. You don't want people hacking your robot vacuum cleaner, right? That's silly. But to be quite fair, though, at the same time, these kind of devices, if people can gain access to them, they contain interesting data, such as my home vacuum cleaner has a lot of information about my home and how many square meters it is, the map of my home, things like that. And although you take it for granted, you have to think of like little things like this. And that's a very good example of that. And where you have to really think about security risks and staying up to date with both the model and the software.
Yeah, no, definitely. Yeah. It's obviously if you had a vacuum in a bank, you don't want that being hacked, would you?
Exactly. Exactly. You have to think about these things. And that's something that's quite important because, yeah, there's going to be use cases where you wouldn't even think about a robot vacuum cleaner falling into this category, but it's another one of those devices. And my vacuum cleaner runs something very similar to a Raspberry Pi. more or less. A lot of vacuum cleaners do, and you can hack it yourself and you can root it, and then you can install your own software. It's called Valtudo. Give a shout out to that community. They're really cool. I appreciate that you can run your own self-hosted vacuum cleaner, which is nice.
Oh, and then touched on a bit on this. How does TinyML fit into the broader landscape of emerging technologies?
Yeah, that's another one of those really big questions, which I'll probably get completely wrong, but I'm willing to speculate as always. I think TinyML goes right into the Internet of Things, and they go hand in hand, really. Like I said, I'm having something with my vacuum cleaner where it can making a TinyML model that runs on it that detects how to clean the floor better, something like that, or avoid certain areas and traps, things like that. For I have an Internet of Things. When it comes to 5G connectivity, I think that's another one of those areas. I hesitate to say, but blockchain maybe when it comes to security. People always overhype blockchain. I still am a big fan of blockchain. AIs for smarter decision making, whether in manufacturing, home, etc. Like I said, medical applications. I think with emerging medical applications in the future, I think that's an area, and I'm not an expert in the medical area with AI, but I think there's a lot of hesitation there because of data and data privacy. And so I could see TinyML being a great solution for that. And I think it will, in the end, hopefully lead us to a truly connected and intelligent world of a lot of little smart devices all around us that just help our everyday lives, help businesses, help things like infrastructure, logistics, etc. And I really hope that this TinyML revolution will happen quite soon. And I feel pretty confident about that. But we'll see what happens. You never know. Maybe something even better will come along.
You have to get involved on it more to speed it up.
We try, but it is hard. I admit, like getting these things running is so hard, but it's going to get easier. And I think in 2, 3, 4 years, it'll be much easier, much more standardized than it is currently than in the last couple of years. And I think we're going to see some really great products coming out for that. And like I said, hopefully they respect people's privacy too, and they don't just connect to the internet and steal all of your data, although they're tiny mouth. That'd be really nice.
Definitely. Cool. Brilliant. That's really interesting conversation, to be honest. And I really appreciate your time.
Thank you very much. I'd love to give a shout out like to Secret Sauce AI, of course, where we do a lot of these fun things. Of course, all of my people at Language Tool, I love those guys. They're really great and fun to work with. And everyone who watches this, shout out to all of you there. I was really happy to be here. Thanks so much, Ben, for inviting me.
No problem. Been brilliant. Thank you for your time.